Hello everyone. Today our group would like to present our cloud computing project, which is about a car rental system that employ in our AWS service. And here is my member, Go Yumin, Go Waiting, and Mo Yong Kang. So let's start from the phase 1 until our phase 4 and also the additional phase.
So my name is Mo Kang. So now I will present the phase one. And so this is our learner place. And let's go inside our console. And this is our console. So we click the VPC. In this VPC, we're having the VPC called current VPC. And next we click the VPC ID link. See the resource map. And in the resource map, we are having two route table and four subnet from two zones. And the private route is connected to the private subnet, and the public route is connected to the public subnet. When we are going to the subnet, so we go to the subnet, we can see the subnet having the subnet public 1.2 and private 1.2 with different zone. And the next we will go to the security group. So in the security group, it named my current server, and in the inbound rule, we install the SSH with 22 port. It is using for development, and the HTTP is for the access the server. And the next we go to the outbound. In here we can see the port range is setting as all. And the next we go to the EC2 server. And the instant part. So in the instant part, we can see the server is held on the EC2 instance called my current server, and looking for the detail. And looking for the detail, we are setting the IPv4 is elastic IP, so it will not to be changed every time. And when we restart it, and the current server elastic IP is we can show the current elastic IP. So we can see the elastic IP called the current server elastic IP is same with the IP just now. And now we go back to the instance. So our instance type is T3 micro. VPC ID is connected to the VPC that I said just now, and the subnet ID is connected in the public subnet zone 2. And the security. So in the security, we can see the security group was connected to the instance, so it will only accept the SSH and the HTTP access. And the next, we will go back to the instance, and we will copy the elastic IP. And now we put into the browser, and it will show this website. So this is our website. And after we log in the admin page, now I will log in the admin page. So the admin page having the dashboard, view car, user manage, and staff manage, and so on function. Next, I will show the function add, edit, and delete. So now we go back to the car, and we go to click the add new car. And now I will add a car. After we click adding the car, it will show at the table the new car information. And now I will show the edit function. Click the button edit. Like I want to update the capacity into like 5. And we click the update car. So you can see the capacity become 5 already. And now I will show the function delete. So click the edit and click the delete car. Click the OK. And in the table, it will show the car that just added is deleted. So that's all for my part. And now I will pass to my teammate.
My name is Goyomin, and now I would like to go through to present for the phase 2. For the phase 2, we focus on setting up the database layer using the Amazon RDS. First, we go to the VPC, and under the security group, we create one more security group called DB security group. And for this DB security group, we also create the inbound rules for it. It is allowed the TCP to access our instance and the server. So we go through to the subnet because we also create the 2 private subnet under this DB security group. These 2 private subnet are confirmed that only the public accessible for our RDS instance, so it can make the security for our RDS instance and authorize for it. After that, we go through to create the RDS. And for the RDS, we click on the database. Here is the database called current $1 that we already created before, and we click on it to see the details. Other than that, we can see the status is already available, and the engine we use is about the using of the MySQL community. And for the networking part, we're using the VPC that we created in the phase 1 before. And for the subnet group, we also using the subnet group that we already created before, and the subnet is under the private. It means it is not publicly accessible. And we also click under the VPC security group. And after that, we go through to the configurations. For the configuration, we can see for the availability part, here is the master username and master password that we created before. And for the instance class, the type using the db.t3.micro. And it is the single availability zone. And then we go back to the connectivity tab. For the connectivity tab, we copy the endpoint and we go back to connect with the instance. Before connect to the RDS, we need to edit the environment file by using the RDS endpoint. And now we would like to using the endpoint that we connected before to open the environment file to see the configuration of our RDS database. So we can look down, here is the database connection we're using the MySQL, and the database host is using the database endpoint, and the DB port is we already set out before and already set out all of the database name and also the username and also the password that we set up when we create the RDS. After that, we exit the environment file, and then we can connect to the RDS using the environment endpoint. The output shows that we already entered the password and already show that we connect to the RDS successfully. So we would like to show the database first. And this database shows that the current level already in our RDS. So we would like to use this database called current level. After that, it will show that the database already changed. It means that we already using this database and we go through to want to see the data in the database that we want to use. So it will show the overall table name and the table rows in our database that we already installed before. And after that, we would like to select the user to see the details. It will show all the users already installed in our database. After that, we go through to the website to do the view, edit, add, and delete operations. And we would like to create one of the account to add the users. We enter for the email address, the password, and confirm the password, and tick the agreement. After that, we create the account. It will show the registration successful, and it will send the OTP code to verify our email. After we copy the OTP code and verify our email, it will show that the email verified successfully. And we can go back to the EC2 instance, view the information of our table. It will show that the users already been entered successfully. After that, we go back to the website and we would like to edit the user profile. And we change for the profile information, the username we change to Sakiri, and the full name we change to Sakiri Chen. And the nationality we edit to Malaysian. And then we update the profile. It will show the profile updated successfully, and we go back to the EC2 instance. And we show the table again. It will show the username and also the full name already be entered successfully. And after that, we go back to the account and we sign in to the admin user's account. Enter for the admin email address and the passwords and log into the admin dashboard. And we click on the users panel and find the users that we added just now. And we would like to delete this account. After we delete the account, it will show the users deleted successfully, and we go back to the EC2 instance. And show the table again. It will show that the users already been deleted successfully. That's all from me. I will pass to the next member to present.
And my name is Chen Junxu. Now I would like to present about the phase 3 about the load balance. And now, firstly, we go through the EC2. In the EC2, in the left sidebar, we choose for the target group. And there's a target group named current family that we created before. And the listener is listened in the HTTP port, and the load balance I will explain later. And the VPC we set here is the VPC that our group member mentioned before. And let's go through the load balancer. So in the load balancer, you can see there are a load balance created named current load 2, and we go through it. And as you can see, the VPC is also the VPC we mentioned before. And for the availability zone, the two subnet we attach here is the public subnet, so that every one of the user can access through our server through this load balance. And in the resource map, I would like to mention for the listener is the HTTP listener. And while there are some requests sent into this port, it will follow the rules that's set in here, which is forward to the target group and send the rules to the target group. And the target group will balance forwarding the request into our target. And as you can see, here is the two target, which the first one is the original EC2 instance, and the second one is about the auto-scaling image that we will mention later. Next, go to the security tab. And as you can see, security tab here, we set the security group same as our original EC2 instance, so that there are only the SSH port and also the HTTP port that can be accessed by public. And next, I would like to show about the DNS that the user will access. So we copy the name and we go through the website and we paste it, enter. So as you can see, this website showing is the exactly same with the original EC2 instance that hold our server. There's nothing different here, and also can log in for the user patch. Okay, so that's all for my part. So now I would like to pass the floor to the last group member.
So my name is Goiding, and for the beginning, let me see for the AMI first. We have created an AMI named current image for our existing my current server in the instance list. And this is ensure that new instance launched by auto-scaling are identical to our original configuration. So go for our launch template. We integrated this AMI into launch template named current template, and let me go for details. After that, instance type, we have selected the T3 micro and applied the same security group configuration as the original EC2 instance to maintain consistent access control. After that, moving on to the auto-scaling group, we have created a current auto-scaling group. Then we go for it more details. And as you can see, that currently our desired capacity is 1, with the scaling limit 1 to 5 instance. And for the launch template, we'll be using the current template, which just mentioned before. AMI ID using the IMI image that was created before, and security group will also same as the EC2 security group. And last, for the instance type, we are also using same as the T3 micro. So for the network part, we have deployed across these two availability zones and with the private subnet ID. And after that, go for our automatically scaling. So as you can see, to manage the scaling logic, we have applied the target tracking policy called current policy 2, which aims to maintain average CPU utilization of 15% and can automatically add or remove instance as needed. Then let me show the CloudWatch first. And go to all alarm. The status for our alarm height, as you can see that it was in OK status, which means that now does not in overwhelmed situations. And next, I would like to demonstrate the auto-scaling test to verify our setup. Before that, I would like to mention that we use Apache very much to perform a load test, while Amazon CloudWatch was used to monitor CPU utilization and trigger the scaling policy. So by copying the EC2 instance DNS endpoint, and we try to execute a load test command that send 1 million requests with 2,000 concurrent connections, and place enter, which will cause a significant increase in CPU utilizations on the EC2 instance. After that, let me go back to the CloudWatch again, and let us wait for a while.
A few moments later.
So after wait for a moment, as you can see that the alarm height status is already changed to in alarm, and indicating that the auto-scaling policy was successfully triggered due to the high CPU utilization. Then when we return to the EC2 instance list, we could see that newly launched EC2 is still running under the auto scaling group. This confirmed that dynamic scaling was successfully performed in the response to increase the system load. So that's all for my part, and I would like to pass to the next presenter. Thank you.
So now, to enhance our understanding of the AWS service, we also implement the S3 bucket, API gateway, Lambda, and also AWS text track to perform a driver license verification process, which is located in the user account patch. In this session, the user is able to upload their driver license in here. So let me show the S3 bucket first. So as you can see, we totally have two buckets here, which is named current bucket and also license 10 bucket. So the license 10 bucket is a temporary bucket. We'll store the driver license document that uploaded by the user and waiting for the verification process. And the current bucket is a permanent bucket that will store everything, including the car image and also the user document. So let's have a look. Now it's empty. So while the user upload the document here and click the upload document button, it will post the request to the backend, and the backend will post the request back to the API gateway, which is named the license verifier API. So we go through it, and you can see here's a post API, which is a HTTP API that will trigger the Lambda function. So we go through the Lambda function. As you can see, the trigger Lambda function is named as request upload, and it's written by JavaScript, and go through it. And also, here also mentioned about the trigger way, which is the API gateway, and here's the written code would process for the verification. So let me simply explain it. We prepare for the environment here, including the bucket and also the SQL details. And in the process, it will tag the document from the S3 bucket and send it to the text track service for text extraction. And it will compare the extracted text with our target keyword, which is the driving license, driver license, and also others. After that, it will return the status and also the extracted word back to the API gateway and back to the backend and show in our front end. So let us demo. So we click on the button, and here is the fact document we prepared, and here is the real one. So let me test for the fact one. When we select it and click on update, and we go through the temp bucket. And as you can see, the document already uploaded here and preparing for the verification. So we back to the web page, and it shows that unsuccessful because does not appear to be a valid driver license, and the text detected here. So let us try for the real one, the text, and we click on the update document. And you can see the contact information upload successfully, and it show the picture here. And we can go to the document and have a look here. We try to refresh and driver license, and you can see the modified time is exactly the same time. So there's the picture upload here. So that's all from our group presentation. Thank you for watching.